Recording again. Again, I will not be, finishing this in one sitting only. Hanggang sa makaya lang natin kasi it's almost time naman na din. Simulan ko lang siya with our adrenoceptor agonists and sympathomimetic drugs. So, we are now on the sympathetic nervous system. We call that fight or flight. And this is governed by the major neurotransmitter, which is the norepinephrine. So, kanina, we talked about acetylcholine, the drugs that mimic the ACH, the acetylcholine, and the drugs na nagbablock doon sa muscarinic and nicotinic receptors. Now, this time, we'll be moving on to our sympathetic nervous system, which is governed by the neurotransmitter norepinephrine, which is the major neurotransmitter found in the postganglion na neuron. Kasi yung sa ganglion nito, remember, acetylcholine pa rin naman. But nevertheless, pag sinabing sympathetic nervous system, since this is governed by the norepinephrine, most of the organ systems are being affected by this, but this is crucial for the regulation of our blood pressure and other cardiac functions. Now, aside from norepinephrine, we will talk about epinephrine also, which is actually a hormone. It acts as a hormone compared to norepinephrine na it is a neurotransmitter. Just remember, norepinephrine is being produced by a neurotransmitter. Norepinephrine is produced by a neurotransmitter, neuron, which is called adrenergic neuron, while epinephrine is produced by our adrenal medulla. So it's a gland, kaya mas tinitingnan natin siya and we consider it as a hormone. Okay? So, ito yung kaibahan nila. Nasabi ko na to kanina, but just a little review. When you say hormone, syempre again, galing sa endocrine glands, while our neurotransmitters are produced by our neurons or our nerve cells. Now, the hormones, after being released, can travel all throughout the body since mare-release din siya sa bloodstream. I mean, mapupunta siya sa bloodstream natin. However, si neurotransmitter, after exocytosis, in the synapse, after the synapse, we have the post-synapse, right? Where we can find the receptors. And if not degraded, the neurotransmitter can directly bind to it, to the receptors. So since the hormones are traveling all throughout the body, it may have slower effect compared to our neurotransmitters. So if we're going to talk about the endocrine system, that is where we talk about the hormones. But since we are talking about the nervous system, so we will concentrate on the neurotransmitters. So for the neurotransmitter again of the sympathetic nervous system, we have our norepinephrine, which is produced by our adrenergic neuron. So just like our acetylcholine, meron tayong precursor for this. So this time for norepinephrine, we have the tyrosine. That is the amino acid tyrosine, but since it's an amino acid, it is considered also a big molecule. So it needs a transporter first with the help of sodium also for it to be able to enter the axon of the adrenergic neuron. Once inside, it will undergo series of processes and then conversions also until maging dopamine siya. So from tyrosine, through the enzyme tyrosine hydroxylase, it will become DOPA. And from DOPA, through the action of the DOPA decarboxylase, it will become dopamine. Now, because of the presence of the MAO enzyme, we have the monoamine enzyme inside the body. Dopamine will be stored in the vesicle. So ito, just like the acetylcholine, ayan, ilalagay din siya inside the vesicle. So the one responsible for that is the VMAT, that's the vesicular monoamine transporter. Itatago sa loob ng vesicle si dopamine, and that is where it is converted to norepinephrine using the enzyme dopamine beta hydroxylase. So ito yon. Now, just like acetylcholine also, it needs the help of calcium para sa exocytosis. Pag nakapasok na yung mga calcium inside the cell, there will still be fusion of the cell membrane and the vesicle, and then the gates. Parehang gates yon. We have the snaps and the vamps. They will be opened, and then after that, the exocytosis. So the norepinephrine will be released. However, unlike the acetylcholine, mas maraming fate itong ating norepinephrine. After being released in the synapse, number one, meron siyang chance to bind to the receptors. So we have here postsynaptic receptors, the alpha-1, beta-1, beta-2, and beta-3. While the other one, the other receptor, the alpha-2 to be specific, is a presynaptic receptor. So it is found here. Now, aside from that, number two na fate ni released norepinephrine, it may be degraded by the enzyme COMT, though it is not written in the screen or in the PowerPoint presentation. But outside, COMT is present, that's catechol O methyltransferase. It's an enzyme that will degrade catecholamines. So norepinephrine is a catecholamine, so pwede siyang ma-degrade. Now, aside from that, 90% of the released norepinephrine is being taken back to the cell through the net. The net, this one here, the circle here, is called norepinephrine transporter. The main action of this transporter is for the reuptake, meaning the released norepinephrine will be taken back inside the axon of the adrenergic neuron. And once taken up, the norepinephrine will also be degraded by the MAO. Remember, I have mentioned a while ago that we have MAO here, the monoamine oxidase. So that's another enzyme that will degrade monoamines. And since norepinephrine is also a monoamine, pwede din siyang susceptible din siya for degradation. Now, if we're going to look at their structures, you have here the tyrosine, our precursor amino acid. Diba? Remember, it will become DOPA inside the cell. Well, after mahimo siya DOPA, it will become a catecholamine na. Remember, this one here, the benzene ring with 2 hydroxyl groups are considered catecholamines. Catechol muna. And then the presence of the amine here, that makes it a catecholamine. And then afterwards, we have the dopamine. One of the, this part here is being removed. And then we have the noradrenaline, the addition of the OH here on the beta carbon. And then after that, we have the adrenaline, which is our norepinephrine. So noradrenaline is norepinephrine, adrenaline is epinephrine. We have here the addition of the methyl group in the amine. So that's the difference between noradrenaline and the adrenaline, or norepinephrine to epinephrine. Okay, so that is just addition or removal of functional groups for us to produce chemicals inside the body. So I have mentioned the norepinephrine transporter a while ago. Again, the main function of that is for the reuptake, taking back of the cells of the norepinephrine inside the cell. So norepinephrine will be degraded by MAO inside to dihydroxyphenyl glycol. Now, the drugs that would mimic the actions of both epinephrine and norepinephrine inside the body are called sympathomimetic drugs, or we call them sympathetic agonist or adrenergic agonists, since they are able to bind to the receptors and elicit pharmacologic action. Now, we also have direct agonists, syempre, kagaya nung ating acetylcholine, yung ating agonist sa muscarinic and nicotinic receptors a while ago. Merong diretsong nagbabind sa receptors, meron ding hindi. Pero the action is still dumbbells. So dito naman, we have direct agonists. Syempre, we have the norepinephrine and the epinephrine there. And we can also add the dopamine. Okay? Now, ang indirect acting nito is more on the release of the catecholamines or our epi and norepi. Most of the time, it's on the norepinephrine release from the vesicle. So these drugs will aid the release of the norepinephrine in the vesicles, and then that will lead to the increase of free norepinephrine that has the ability to bind to the receptors. So yun. Before we'll talk about the receptors of the norepi and the epinephrine and the activities of that, let's talk about first the indirect acting agonists. So they have two mechanisms of actions. Number one is the displacement of stored catecholamines from the adrenergic nerve endings. Hindi ako marunong magsulat sa screen sa Google Meet. Kasi pag sa Zoom, madali lang akong mag-note. No, pero pag-aaralan ko yan. But nevertheless, ngayon muna, remember, our norepinephrine is being stored here in the vesicle. And we have drugs and chemical substances that will help displace this norepinephrine and increase the rate of exocytosis. So again, that will increase the free norepinephrine here in the synapse. And mas malaki yung chance na makabind siya sa receptors. And then, number two, we have drugs and chemical substances also that would inhibit the NET, the norepinephrine transporter. So, in simpler terms, these drugs will inhibit the reuptake, yung ibabalik natin sa loob ng adrenergic neuron yung ating norepinephrine. So we have the following drugs here. Yung tyramine, which is found in our food products like sa beer, sa cheese, sa chocolates natin, and sa red wine. This will, take note, help in the exocytosis, the displacement of the catecholamines from the storage inside the vesicle. Now, that will increase norepinephrine. And if taken together with MAO inhibitors, since dadami yung norepinephrine tapos ininhibit mo pa yung enzyme na sisira kay norepinephrine, talagang tataas yung amount ng norepinephrine mo, which are free to bind to the receptors, and that will lead to hypertension. Tataas yung blood pressure ng patient. The MAO I'm talking here are those MAO inhibitors used for depression. Now, other than that, we also have cocaine, amphetamine muna, which is used for ADHD, and since this can increase norepinephrine in the body, it can stimulate everything, including our CNS. This can suppress the appetite of a person. So, ito naman would also inhibit the NET. Okay, just like the tricyclic antidepressants and the cocaine also. Now, kung direct acting yung ating drugs, syempre dito sila sa receptor magbabind. We have alpha and beta receptors. We have 2 alpha and 3 beta receptors. And for dopamine, we have dopamine receptors. Now, their structure will actually, their structures will dictate their affinity to this receptor, since maraming ang receptors sa ating sympathetic nervous system. So, meron tayong tinatawag na receptor selectivity. So, just like norepinephrine, the selectivity between alpha-1 and alpha-2 is just equal. But when it comes to the beta receptors, mas mataas yung affinity ni norepinephrine sa beta-1 compared to the beta-2. However, for epinephrine, the difference is for beta receptors, pantay yung affinity. Okay? So, meron ding receptor selectivity when it comes to alpha and the beta receptor. So, sa alpha receptor, ang pinaka nagbabind si epi, and then equal or more than yung kanyang affinity compared to norepinephrine. Pero, syempre, mas malayo yung sa isoproterenol. But isoproterenol is mas mataas yung kanyang affinity sa beta receptors, but it is followed by epi and norepinephrine. So this will actually explain why we use epinephrine for our anaphylactic shock than our norepinephrine, since we need the person to have bronchodilation, so kailangan natin yung affinity ni epinephrine sa beta receptors also, especially sa beta 2 receptor. And then yung sa alpha receptors also to increase the blood pressure, since sa shock there will be a downfall in the blood pressure. So yan yung mag-explain the receptor selectivity. So dito, the receptors, the affinity to the receptors will be explained sa kanilang chemical structure. So all of our sympathetic nervous system na mga agonists, or we call them adrenergic agonist, or anong tawag doon, sympathomimetic drugs, ang parent compound nila is si phenylethylamine, which means meron siyang phenyl group. The ethyl group, meaning meron tayong dalawang carbons, we call them alpha and beta carbons. And the last functional group is the amino group. So silang lahat merong ganon. It's just that some of them have complete OH or hydroxyl group on the third and fourth position in the benzene ring. Kaya yung iba tatawagin natin catechol. And because of the presence of the amine group, thus we call them catechol amines. So, yung mga functional groups na nilalagay natin on those parts, 3 parts here, will dictate their action or their pharmacokinetic profile or their receptor selectivity. Okay, so just like in the benzene ring, if the hydroxyl groups, yung dalawang hydroxyl groups are present in the benzene ring, which makes them a catechol, they will be subjected to degradation by the enzyme COMT, that's catechol O-methyl transferase. And because of that, the drug will not be orally bioavailable kasi COMT is found in the gut, in the gastrointestinal tract. So talagang masisira yung lahat ng drugs with the catechol structure. Okay, pag ininom natin siya orally. Kaya yung mga epi nor epi natin, and even the dopamine, they are all given parenterally. However, if we are going to remove one or even both hydroxyl groups from the benzene ring, they will still retain their action in the sympathetic nervous system, but they will not be recognized by the COMT enzyme. So by that time, these drugs will be available, bioavailable orally. We can give them orally, just like the phenylephrine, which is less potent than epinephrine, but the advantage is we can take it orally because of the absence of the hydroxyl group. So if we are going to look at the structures of these drugs in the sympathetic nervous system, we are going to look at their benzene rings. They have either one OH or talagang walang OH. Kaya ang mangyayari, pwede silang ibigay orally. Unlike doon sa, if we're going to go back like this one, the dopamine, the norepinephrine, and the epinephrine, meron silang dalawang OH. So they are considered catechol. Okay? So that is for the benzene ring. Now, we have for our amino group. For our amino group, if we have substitutions on the amino group, especially if malaking alkyl group yung substitution, that will shift the activity or the affinity of the drug to the beta receptors. So, yung kanyang affinity, pag may nakita tayong substituent on the amino group, magiging mataas yung affinity ng drug na yan sa beta kaysa sa alpha receptor. So if we are going to look into the isoproterenol, this is the structure of isoproterenol here. It's still a catechol-amine though, since we have here the catechol and then the amine. However, if we look at the amino group, merong isopropyl dyan na substituent. And that means, that explains why kanina, sana yan, yung affinity, when it comes to the beta receptors, talagang mas mataas ang affinity ni isoproterenol compared to the other drugs. Okay? Now, for the alpha carbon is the carbon beside the amino group. Okay? So, kapag meron yun siyang substitution dyan on the alpha carbon, it will block oxidation by the MAO. So, yung kanina sa benzene ring, pag tinanggal natin yung OH, 1 or 2 of the hydroxyl na functional groups, mawawala yung action ni COMT. This time, pag nilagyan mo ng substitution on the alpha carbon, that's the carbon beside the amino group, mawawala ng action si MAO. So that will prolong the activity of our drugs. So just like ephedrine and amphetamine, meron silang substitution on their alpha carbon. So ito si ephedrine, this is the amino group here. The next carbon here is this one. This is called the alpha carbon. So meron yan siyang substituent dyan na CH3. That is also true for amphetamine and methamphetamine. And then again, that will result to the blockade of the action of the monoamine oxidase enzyme. Okay? So, mapoprolong yung kanyang duration of action compared to other drugs. Now, how about on the substitution on the beta carbon? Most of our direct-acting agonists on the sympathetic nervous system have substitutions on the beta carbons, except for dopamine, but they don't really have a direct effect on the activity of these drugs. So, wala masyadong activity when it comes to their pharmacokinetic profile, kung maprolong ba yung action nila, or maiiba ba yung effect nila, wala. Meron lang talaga silang substitution on the beta carbon. The beta carbon is the second carbon beside the alpha carbon. Okay? So, I think I'll just end here since it's almost time and toxic na kayo, daghan na kaayo. Next meeting, we will continue with the receptors of the adrenergic system or the sympathetic nervous system, and then we will also discuss the drugs and the agonists and the antagonists, and then after that, we will have our reporting starting with hypertension and yung isa pa, the heart failure. So, assigned reporters, please prepare.